Hello class. Today we're going to work on Chapter 10, Triangle Trigonometry. Triangle trigonometry is very important in any kind of trade that you're working with, whether it's welding, machine tool, engineering. It's just a very important concept. So we're going to start that today, okay? The first thing we're going to talk about is radian measure. You know, there's different ways. There's engineering method, there's radian method, there's degrees, polar, all types of different measures. But today, just for a minute, we're going to talk about radian measure. When you get ready to take INT 104, Principles of Technology, which you may have already taken or you're taking now, radian measure is one of those topics. So I want to make sure I cover it in here. In scientific work, angles are measured or described as an angle unit called the radian. So angles are described and it's called a radian. And one radian equals 180 degrees divided by pi. And this is approximately 296 degrees. Okay? So that's a good little formula there to know. One radian is the angle at the center of a circle that corresponds to an arc exactly one radius in length. So if we had a circle, I know that looks more like an egg, but if we had a angle here, A, well, these two R's here, A equals 1 radian or about 57 degrees, okay? Angle A, so another way to look at it would be angle A divided by the total angle in a circle. Okay, and then if you talk about circumference and so forth like that, you can get this formula here, A equals this. Okay, so we won't get through the theory behind it, but just so you know that. Now, what is it? Why is this important? Well, we can use radians and we can go between radians and degrees or degrees and radians. So let's talk about degrees to radians. So degrees to radians. How do we do that? Well, we know that 180 degrees divided by pi is 1 radian. So we can use that to our advantage to convert between that, okay? So we're going to use this formula here, and we're going to do those conversions. So I'm just going to show you kind of an example. It's the easiest way. So if we have 43 degrees and we wanted to convert that to radians, we would say 43 degrees times pi over 180 degrees. Okay? And that is going to equal 43 degrees pi divided by 180 degrees. When you do that, 43 times pi divided by 180, you're going to get 0.75 radians. 0.75 radians. So we can do another one. If we had 60 degrees and we wanted to convert that, that would equal, same thing, 60 degrees, pi over 180. Now, notice that the formula that I showed you was 180 over pi. That's 1 radian equals 180 over pi. So if you're changing that to degrees, you have to rewrite that. So it's pi over 180. That's why it looks different. So then that's going to equal 60 pi divided by 180. And that's going to be approximately 1.0472 rads. Okay? So that's how you do that, okay? Now, what if we wanted to go from radians to degrees? So to convert angles from radians to degrees, you're going to use the other formula, okay? So for this type, you're going to use this formula. I should have wrote this down. Radians equals degrees times pi over 180. So that's the formula, that's the formula to go from radians to, degrees to radians. Now, to go from radians to degrees, it's going to be degrees equals radians, and we can just call it rad, times 180 over pi. Okay. Now, let's do this one. 1.3 rad equals 1.3 times 180 over pi. We do that, we get 1.3 times 180 over pi. That's going to be approximately 234 divided by pi, which is 74.5 degrees. Okay, so that's going from radians to degrees. So we'll work with more. 0.5 rad equals 0.5 divided by 180 pi equals 0.5 times 180 divided by pi, and that's going to be approximately 28.6 degrees. So that's how you convert between the two. And again, if you've taken INT 104, you'll need to know that. If not, you still need to know it when you do take that. Okay. Let's talk about sectors for a minute. The wedge-shaped portion of a circle is called a sector. Both its area and the length of an arc S can be exposed most directly by using a radian measure. So that's why we're going to talk about this. Okay. So again, let's put that circle up here, and if we have this angle here, this is R and R. This right here is the circumference. Okay. Nope, sorry, this is the sector. The circumference is the hole around the circle. So how do we find this? Well, arc length, and this is the arc length. Arc length equals S equals RA. Okay. The R here, the line, times the angle. Now for the area, we'll do a problem here in a second. It's 1/2 R squared times A. 1/2 R squared times A. Now, the sector formulas will not work unless the central angle is in radians. So the A has to be in radians, and you can change that in your calculator. It's under like the engineering units and things like that, okay? So if you just scroll through it, you'll see one. If you have the TI-30XA, you change it up there where it says degrees, and you'll see where it says RAD, rad. That's the radians. So anytime you're working with radians, you have to be in radians. So let's just easier to look at a problem. So let's look at a problem. A sheet metal worker wants to know the arc length and area of a sector with central angle 150 degrees cut from a circular sheet of metal with a radius of 16 inches. So the first thing I always do is draw the circle, okay? So it's going to look something like that. I know it's not perfect. This is going to be 16. This is going to be 150 degrees, okay? So first you calculate the angle. Well, let's write down everything first. So we got a sheet metal worker wants to know the arc length and area of a sector with a central angle of 150 degrees. So A is going to equal 150 degrees. And radius is 16 inches. So R equals 16 inches. Okay? So now let's see what we got. So it's wanting to know the arc length and area. So we want to know arc length first and then area. So for arc length, that's going to be A equals, we got to change A into radians, remember? It's going to be 150 degrees times pi over 180. And that's going to be approximately 2.618 rads. Okay, so we got that. We got it converted to radians. So now we can find the arc length. So S equals RA. So the radius is 16 inches times the A in radians, 2.618 rad. And that's going to approximately be 4.19 inches for S. Okay? So we got S, which is the arc length, and now let's find the area. So the area is going to be 1/2 R squared A. So that's going to be 1/2 times R, 16 inches, squared, times A, 2.618 rads. And that is going to equal, when you do all that math, that's going to be 335 inches squared. Now what I suggest you do is try to do this math without just watching this. Try to do it with your calculator and see what you get, okay? Now, radian units are also used in science and technology to describe the rotation of an object. When an object moves along a straight line for a distance, d, in time, its average linear speed, v, is defined as v equals d, which is distance over time. This is your linear speed. So you can also use this in physics. So if a car travels 1,800 feet, so d equals 1,800 feet in 24 seconds. So our time is 24 seconds. Always, even when you get to your other classes, make sure you write all your givens and your formula and a drawing if you need it, and that really helps you understand the problem, okay? Now, what is the average linear speed for the trip? So use the formula v equals d over t. So distance is 1,800 feet divided by 24 seconds. So that's going to be 75 feet per second for our velocity. So it's going 75 feet per second. When an object moves along a circular arc for distance s in time, it goes through an angle a radius, and its average angular speed is defined as this. Angular speed is a over t. Okay? This is angular speed. So that was linear speed. This is angular speed. Okay? So let's look at that. If we have if a 24-inch diameter flywheel rotates through an angle of 140 degrees in 1.1 seconds, what is the average angular speed of the flywheel? So first you got to calculate in radians. So again, you got to find A in radians, but let's write this down. So A is 140 degrees. T is 1.1 seconds. Okay? But remember, we got to convert this to radians. Convert to rads. So to do that, remember, we go A equals 140 degrees times pi over 180 equals 2.44 rads. Okay? So now we can do our formula, A over T. A is going to be the 2.44 rads divided by 1.1 seconds. Okay? So that's going to be approximately 2.2 rads per second for our angular speed. And see, all this we do in physics too, okay? So I think this will help you guys. Now let's go to right triangles. So a triangle that contains a right angle is always 90 degrees. Okay? So for right triangles, so we're going to draw a right triangle. And this is always 90 degrees. Okay? So now what I want to show you is like what the hypotenuse, side angle and all that is. So our hypotenuse is the side opposite the right angle. It's always the longest side. So here's the right angle. It's opposite of the right angle, and it's always the longest side. Okay? And it's called the hypotenuse. And we abbreviate that to HYP. Hypotenuse. Always the side opposite the right angle. Now let's talk about the Pythagorean theorem. This was out of chapter 8, so it's not new, but this is going to help you find the other sides, okay? So remember, in the Pythagorean theorem, we said c squared equals a squared plus b squared. Okay? A and b are the legs. A and b are the legs. And c is your hypotenuse. So let's look at an example. This will help you. All right, so we got our triangle. We got C, 36, 15, and there's that. So C we know is the hypotenuse, don't we? So we're missing C, the hypotenuse. So if we got C squared equals A squared plus B squared. So A squared is going to be 15 squared plus 36 squared. That's going to equal 225, 5 squared is 225, plus 36 squared, which is 1296, c squared. So now, the thing is, see this c squared? We got to square root the both sides of that. Okay, so that goes away. So then we have c equals, when you add those together, you get 1521 square root. So if you have the TI-30XA that I've suggested to get in class, you do 1521 and then hit the square root. It's a square root with an x over it. And that gives you 39. So c equals 39. And that's how you find the hypotenuse. Okay, just a quick reminder of the Pythagorean theorem. Now, in most practical work, angles are measured in degrees and a fraction of a degree. So for instance, 60 minutes, now we're not talking about minutes of time, we're just talking about in angles and degrees. That would equal 1 degree, okay, or 60 minutes with one thing like that, apostrophe, equals 1 degree. Different ways of looking at it. Or 60 seconds equals 1 minute, or 60 seconds equals 1 minute. Okay, that's another way to see it. So how do we do this? So to convert 17.5, let's look at an example. 17.5 degrees to minutes. You want to convert this to minutes and degrees. So you follow 2 steps. So step 1. Step 1, you write the angle as a sum of a whole number and a fraction. So it'll be 17 plus 1/2. Okay. Now step 2. Step 2, you use a unity fraction to convert 1/2 to minutes. So it's going to be 17 plus 1/2 times 60 over 1 degree. And when you do all this math, you get 17 degrees and 30 minutes. Okay, 17 degrees and 30 minutes. And that's just a quick example of it. There's a couple of these on the test, so we'll look at that on your homework, okay? All right, so now let's look at a construction problem. You know, this is something that all you guys will be doing, and girls. So we're going to look at this example. So if we have, let me try to draw it. If we have this, okay, we have this 90 degrees, this is 90 degrees, this is Y, this is 12 feet, and this is 8 feet, okay? And this is 22 feet, okay? And this is, I'm going to call this figure 1 because I want to talk about this in a minute. Then what if we draw it again? Try to draw it again. I know it won't be exact. This is 90, this is 90, but now look here. What if we cut this part off? Okay? We're going to call this figure 2. This is Y. This is 22 feet, same as this right here, okay? Now this was 12 here, and we're going to call this 4 feet. And I'll tell you why in a second. So, a cathedral ceiling creates the interior wall shown in figure 1. Suppose we need to find the length Y of the beam needed to go along the top of the wall. So this will be the beam here, okay? So first we draw a dashed line in figure 2 to divide the wall into a rectangle and a right triangle. Note the vertical leg of the triangle, 12 feet minus 8 feet, is 4 feet. So see here, it's 12 minus 8 equals 4 feet. And that's where we get this 4 feet. That's what's left from here, okay? Now, the horizontal leg is 22 feet in length, and we use the Pythagorean theorem to find the hypotenuse. So we've got y squared equals 42 plus 22 squared. Oh, I'm sorry, this is 4 squared. It's like that doesn't look right. 4 squared plus 22 squared, okay? So that's going to equal y squared is 16 plus 484. So y squared equals 500. Take the square root of both sides to get rid of that square. is going to be y equals 22.4 feet. So they need a beam 22.4 feet across to hold that wall up. Okay? So that's a good practical problem there. Now, a trig ratio using scientific calculator. I'm going to try to do this. I know you can't see it, but I'll talk you through it, okay? So we're going to talk about trig ratios, but I want to show you kind of how to do it real quick. So to find sine 38 degrees, depending on your calculator, you may do this a couple of ways. So one, if you're using the one that I told you to get, the TI-30XA, you'll type in 38 and then you'll click the SIN button, and that'll give you 0.6156 and so forth, okay? So you'll click 38 and sine. Oh, I have it in radians. Make sure that you take it back out of radians and put it back in degrees, okay? So 38 sine is 0.61566147.5. Yeah. Make sure once you finish those radian problems, you convert that, okay, back to degrees. Now to find the angle. So now that's pretty easy, right? Now some of you guys, calculators, you'll actually hit the sine button. It'll come up like that, and then there'll be a parentheses like that. And you'll put in your 38, another parentheses, and enter. And you should get the same answer. But if you have the TI-30XA or one of those models, you'll type in 38 first and then hit the sine button like that, okay? And that's important. So play around with that and make sure you can do that. Now, what if we need to find the angle? So what if we have sine A equals 0.728? So we're looking for A. So with the TI, you'll type in 0.728, and then you'll click the yellow second button, or green. It's either yellow or green, the second button. And it's yellow or green, depending on which model you have. And then you click the sin, which gives you sine -1. 0.728 is what you're really looking at, okay? So when you do that, you end up with 46.718988. Okay? So for you guys that have the TI-30XA, you'll type in 0.728, hit the second button, and then you'll hit sine. For you guys that have any other type, you might hit second button, sine -1, and it'll have a parentheses. You type in 7.28 and enter, and it'll give you that number. So play around with that. Make sure that you know how to use that for your calculator, okay? All right, so now let's talk about solving right triangles. So right triangle. I'm just kind of giving you some review of stuff, and then we'll get into the nitty-gritty. So solving right triangles. A right triangle has 6 parts. It has 3 angles, a right angle and 2 acute angles, and it has 3 sides, the hypotenuse and 2 legs. We can use trig ratios to find all the unknowns of angles of a right triangle if we know either of the following combinations. So if we know the length of one side and the measure of one side, or the angle, and if we know the lengths of any 2 sides, we can find the rest of it. The easiest way is just jump in it and look at a problem. So let's look at this triangle. If we have this right triangle, we have 21 centimeters here. This is B. This is our angle A, 50 degrees. Okay. Suppose we need to find the side A in the triangle shown. Use the following approach. So we're looking at this side A right here. So step 1, you decide which trig ratio you need. We are given the hypotenuse, so we know hypotenuse equals 21 centimeters. And the acute angle B, our angle, is 50 degrees. 50 degrees. And we need to find the side adjacent to the given angle B. Remember, all right, another remember, SOA katoa. I know I'm not saying that right, but sine opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent, okay? So what we're looking for we need to find cosine B, which equals the adjacent side over the hypotenuse side. Okay? So we write the cosine of the given angle in terms of the sides of the given right triangle. So that we know B, so cosine 50 degrees, or 50, equals A over 21 centimeters. We're looking for A. So now, remember, we got to solve for A. So we're going to multiply A by both sides. Whoops. We're going to multiply 21 first, sorry. 21 centimeters by both sides, and whatever you do to one side, you got to do to the other. That cancels. So A equals 21 centimeters times cosine 50 degrees, or cosine 50. And that's going to equal 13.4985 centimeters. So when you put this in your calculator, you're going to do cosine 50 degrees first. Okay, and that's going to be 0.64278, blah, 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 and then times 21. And that's for the people that's using the TI-30XA. Now, if you have the other kind, you may be able to type all this in at one time, and that's perfectly fine. Just make sure that you can do it both ways. Okay, so that's how you do that problem. Now, let's look at another one, because it just depends on what you're given to which SOHCAHTOA you need, okay? All right, so what if we had this? So we don't know this angle here, but this time we have 11.3 and we have 16.5, and that's our angle A. Now, 11.3, notice it's the opposite and of the right triangle, of the hypotenuse, I guess, and adjacent here is adjacent from the right triangle. So in this case, we're going to use tangent A, and that's going to be opposite over adjacent. And a lot of times it depends on what you have here, okay? Or it does depend on that. So if we just do this part, 11.3 over 16.5, just that piece, that's going to give you 0.6848, and that's going to help us find the other part. Now, we're looking for A again. Remember, when we're looking for that, we use tangent -1, sine -1, or cosine -1 to this number we just found, 0.6848. So again, you're going to hit second, that little second key up at the top. You're going to hit second tangent, and that gives you tangent to the -1, okay? So when you do that, you get 34.4 degrees. And again, please try to type that in and make sure you understand that. All right, now that's right triangles, but what if we have triangles that are not? And we know we have a lot of those. Those are called oblique triangles. That's any triangle that is not a right triangle. And there's two types. You have an acute and an obtuse. And remember, acute is less than 90 degrees and obtuse is greater than 90 degrees. So we're going to use something called the law of sines. And you don't have to memorize this, but it's very helpful. The law of sines states that the lengths of a triangle are proportional to the sines of the corresponding angles. So the easiest way to show you that would be just a picture. Okay, so what if we have this triangle? This is our height H. This is A, little a, C, little b, big A. And D. Okay, and this is C. All right. So the way this works in triangle ACD, so triangle ACD, sine A equals H over B. Or another way to look at that would be H equals B sine A. Okay? In triangle BCD, this triangle, BCD, then it's going to look like this. Sine B equals H over A, or H equals A sine B. Okay? And all that's just saying that the law of sines is this. Sine big A equals over little a equals sine big B over little b equals sine C over little c. Okay? And again, the best way to show this is in a problem. So let me try to draw this real quick. Okay, if we had this triangle, this angle is 47 degrees. This is big A. We don't know B here, okay? A here is going to equal 8 inches. This angle here is 38 degrees. And we don't know C. But we know a lot of pieces, don't we? So for triangle shown, we're going to write it down because it's easier to see. A equals 47 degrees. B equals 38 degrees. And A, little a, equals 8 inches. That's what we have. So find all the unknown parts. Now remember, the angles of a triangle sum to 180 degrees. Okay? So inside this triangle, it has to equal 180 degrees. So we can find this C right here. Okay? So C equals 180 degrees minus A minus B. And that's going to equal 180 degrees minus 47 degrees minus 38 degrees. So that's 95 degrees for C. Okay? A triangle, the sum of the angles in the triangle has to equal 180 degrees. So next we apply the law of sines. So sine A over little a equals sine B over little b. So that's going to equal, B equals, we got to put that together, A sine B sine A. All right, so we plug it in, and that's 8 sine 38 degrees divided by sine 47 degrees. And that's 6.7 inches equals B. Okay? So that gives us B. So now we have A, we have C, we have B. So now we need to find big C. So to find it, again, using the law of sines, sine A over little a equals sine C over little c. So when you put that together, you get C equals A sine C over sine A. Okay? So that is going to equal 8 sine 95 degrees divided by sine 47 degrees. And that's 11 inches equals C. Okay? And that's how you do that one. So that's the law of sines. So the big thing to remember, I'll give you these formulas so you don't have to worry about trying to memorize those. Just make sure that you can solve the problems, okay? Now, last one, law of cosines. Real similar to law of sines. On law of cosines, it's going to be a squared equals b squared plus c squared minus 2bc cosine A. And again, don't memorize these formulas. B squared equals c squared plus a squared minus 2a cosine, ca cosine B. And then c squared equals a squared plus b squared minus 2ab cosine C. So these will all be given. So let's just look at a problem. The law of cosines state the square of the length of any side of a triangle equals the sum of the squares of the lengths of the other two sides, minus twice the product of the lengths of these two sides and the cosine of the angle between them. That's a lot of words, isn't it? But it's really simple. So if we have this triangle, we have A and B, we don't know C. We have this is 92 degrees. We have A equals 22.8 centimeters. And we have B equals 12.3 centimeters. Okay, so notice the given angle C is the angle formed by the given sides A and B. So in that case, then we're going to use the C squared. C squared equals A squared plus B squared minus 2AB cosine C. So C squared equals 22.8 squared plus 12.3 squared minus 2 times A, 22.8, times B, 12.3, times cosine 92 degrees. Okay, so 22.8 squared is 51. You know what? This is supposed to be 42 degrees right here. Sorry about that. 42 degrees. Okay, so 22.8 squared is 519.84 plus 12.3 squared is 151.29 minus 2 times 22.8 times 12.3 is 560.88, and then cosine 42 degrees. Put that there. Just trying to simplify it, okay? So 519.84 plus 151.29 is 671.13 minus 560.88 cosine 42 degrees. Again, this is C squared, okay, because we'll have to do the square root in a second. So then 560.88 cosine 42 degrees is 416.82. Just bring that down. So then we have C squared equals 254.31. Now we need to take the square root of both sides. That cancels. So C equals 15.95. And that gives us our C. So that's how you do this chapter. I've already posted the homework, and I hope this video helps. If you have any questions, please come by to see me. Remember, final is coming up soon. Thank you.